using the standard repetition system may not work that well. But from the talk, it's not clear to me where you leverage the difference in sensor angle to get better result. I think I want to ask, so can you use this approach backwards to the
P2P system?
Yeah.
So I think that the major thing is that in the observability graph, so that defines who you can really interact in the system. In P2P system or in online auction, you cannot define such the observability graph because you cannot specify that you can only talk to Alice and Bob, but you cannot Carol, because anybody can talk to anybody in P2P or online auction. But here we have this restriction. That's why that when I think that this guy is bad, when I assume S is compromised, is not compromised, then I know that all its neighbors must be compromised. But in P2P, you probably cannot say that.
And also in P2P, you probably cannot get the same observation.
Yeah, you cannot. It's hard. In P2P, usually one transaction only involves two parties.
Okay.
And also that in P2P, you cannot just say, because this is a bad transaction, then I'm going to lower the rating of both parties. Then some people are going to complain. But sensors, they're not going to complain. Okay. Other questions? Yes?
Have you experimented with without doing the inferencing part? Because I think for some applications, the inferencing makes sense. But for some applications, maybe you cannot do the inference. Even though two guys, they have an inconsistent view about the node, it doesn't mean one of them is bad. Maybe both of them are good. So somehow they cannot, they're observing different behavior. So have you tried it without doing the inferencing? And in that case, how well is the detection rate?
We didn't try that, but I think that in some applications, it's really not the case that everybody can observe the same behavior.
Right, and so yeah, for those, this is for those kind of applications. I'm just curious.
Yeah, I think that's interesting to try it. We haven't tried that. And actually, another interesting thing is that here we only say that if your security estimation is too conservative. So what happens if actually there are 30 compromised, but your security estimation is only 20? That means in that case, what happens? We haven't tried that because that really cannot give any guarantee about the optimality of the algorithm.
Okay, so let's thank the speaker.